Hey, what's up everyone? My name is Vaughn. Welcome to my channel. And today I want to talk about a proof for the Pythagorean theorem. I just want to make sure we know that in a right triangle, well, any triangle actually, the angles add up to 180. So here we have lambda and theta. So it's 90 plus theta, or minus theta, equals 180. Minus 90 both sides, you get lambda plus theta equals 90. And this is going to be very useful. So let's get down to the Pythagorean theorem and what it's actually saying. Okay, so in a right triangle, the theorem says that a squared plus b squared equals c squared. Okay. So looking at this, it's hard to imagine a squared as a line. It's actually impossible to imagine as a line, but a can be squared like this. So now we have a, and this becomes a squared. Down here, b can be squared like this. B squared, and then c squared. Okay. And what the Pythagorean theorem is saying, that if you add a squared plus b squared, these big shapes, it equals exactly this big shape. So you can fit these two squares into this square. Okay, and this is a point where I suggest you can pause the video and see if you can do some cutouts, or see if you can start slicing it up in your head and see if you can figure out how those two squares, a squared plus b squared, actually fit into c squared, because that's exactly what we're just about to do. So get ready. The first trick is I turn the right triangle like this. Okay, now that's the 90 degrees, which means this is b and this is c here. And I would like to label lambda and theta. Theta is the small angle right here, and lambda is the larger one here. Okay, here we go. The first thing we're going to do is square b. That pretty much looks like the square, okay? And then we're going to square a. Okay. All right, and the last one we have to do is square c, and we're gonna make that one as a solid line. Here we go. Okay. Do we see this? Let's get a little closer. We're gonna go in. That is basically the proof, and what I'm saying here is that this piece of b squared fits over here. This piece of a squared fits up here. And this piece of b squared fits right down there. But this is the interesting part of the video. This is the mathematical part. Maybe this is even the hard part. How can I prove it? Okay, the first thing is that I claim this angle here is a theta. And how do I do that? Because this is a right angle. We said if this is a right angle and this is theta, then this has to be lambda. And we said also that this is a right angle here, b squared. If this part right here is lambda, then this has to be theta. And we know this is actually b right here, and we know this length right here is actually c. So if we have the angle from the original triangle, and we have the length b, we have the length c, and we have so much information, we can actually say this is just a right here, and this makes the original triangle. So immediately the original triangle is developed over here and actually intersects c, because c, a, and b. So that will go over here. So this length becomes b, and a comes like this. So that's A right there, and this is C, and this is B. Okay? We see now that A is here, and this is also A because this is A squared. There's A there. So now we can move this piece up there. Now how do I know that this angle is theta? Okay, well, since this is the original triangle here, we know that this is theta and this is lambda. And lambda is splitting this corner, so the other side has to be theta. So the other side is theta like this. And that's theta too. And so we have A at this angle hitting a right angle. And here we have A at this angle hitting a right angle. So it's the exact same. It's the exact same part or piece of the puzzle. The last one, bear with me right here, is to justify that this corner of B squared can fill in this bottom portion right here. This is a side of B and this is a side of B squared. So it's parallel. So if this is theta, this also has to be theta. And the trick is, what's this length here? This length is B minus A. Okay? And as we see here, this is B and this is A. So this is also B minus A. So it has theta, theta, B minus A, and then it hits a right angle, and this, as we know, is also a right angle. So that pretty much completes the proof. So C is at the base, and the right angle is pointing up. Build B squared, build A squared, build C squared, okay, and the pieces on the outside of the puzzle fit inside the puzzle. You can also do this as a cutout. On a piece of paper, you can make a big square that's B squared. Let's say that was a perfect square. Then the line C is right here. Once you have B and C, here's B, here's C, you know that you have A. Okay, so that's the right triangle. And then you just make a right angle here. Okay. And since we have A right here, you do A squared. And on any corner of A squared, you just take this angle theta, this is lambda, and you just cut it like this, same kind of way, using this angle. Okay. And that creates 5 pieces. 1, 2, 3, 4, 5. And those are the 5 pieces you can piece together to make C squared. I hope you have a great day. Bye.